Okay, guys, I want you to be on this slide, please. When we talk about compound interest, this is probably one of those things that you're going to be like, oh, this actually applies to stuff in the real world. Because a lot of stuff I know we do in here, like, when am I ever going to use this? Compound interest, this is the formula for it. I am not sure if you're going to get this formula on the test or not, and I have to ask Ms. Carver. I'm not sure what she plans on doing, so I'll let you know at a later date. But I want you to know what each piece of this formula represents, okay? Principal, this big capital letter P is the principal. Does anybody know what principal means? Not Mr. Molina? The principal is the amount that you begin with. It's the amount you start with. All right, so when they say the principal or you invested a certain amount of money or something like that, that's the amount of money you started with. Then you have this R. R is your interest rate. Now, something that is really important about the interest rate is it has to be, in the formula, it has to be a decimal. It has to be a decimal. When you do your calculations, you cannot leave it as a percentage because then your numbers are going to be crazy off. T is the variable for time, and it's in years. And then N, this one's a little tricky here. N is how money is compounded, because we're talking about compound interest. You'll see that word, it'll be compounded a certain way. So your N value in both cases. If something is compounded monthly, how many months are there in a year? 12, okay? So your N value, if something is compounded monthly, your N value is 12. What about if it's weekly? How many weeks are in a year? Uh-oh. How many weeks are in a year, guys? 52, okay. What about if it's daily? How many days are in a year? 365, good. What about if it's quarterly? How many quarters are in a year? How many quarters are in a dollar? 4, good. What about if it is semi-annually? I don't think I spelled that right.
6.
Okay, it's 6 months, but we're going to talk in terms of years. So semi-annually happens how many times a year? How many? 2, good, 2 times a year. And if something is compounded yearly, what's the number? 1. You guys need to know these. You've got to know when you see the word monthly, that means 12. Quarterly means 4. You have got to know when it says how the money is compounded, you have to know what those words mean. Super duper important, okay? Plugging into the formula is not the biggest issue. Usually our biggest issue is plugging it into the calculator. So we're going to talk about that in a little bit here too. Okay. Did you get all that? Let's look at this. It says you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. Okay, so let's talk about this. First of all, let's write our equation. It's P times 1 plus. What's the rest of it? What's the little fraction? R over N, okay? Raised to the what? NT power. Okay, so let's talk about in this formula or in this word problem what they told us. What is $9,000? That's the P. That's what you started off with. Okay, so $9,000. It says an annual interest rate, so that's my R, is 1.46%. Is that a decimal? No, it has a decimal point in it. I understand that. But it is a percentage. How would you change that to a decimal? We're going to move the decimal place where? To the left, 2. So what you're going to plug into your formula is 0.0146. If you guys don't do that, if you plug into this formula 1.46 and not 0.0146, your number is going to be way off. So remind yourself, put a little star next to that. Whenever you have an interest rate, you have to move the decimal 2 to the left. Even though there's a decimal point in it, that's fine. You still have to move it. Does that make sense? All right, what's the time? How many time in years we talk about? After 3 years, good. And then how the money is compounded. That's my n value. How is this compounded? Quarterly. How many quarters are in a year? 4, right? Everything that you need to put into the formula is going to be given to you. You just need to know how it's represented. You need to make sure your interest rate is correct, and then you need to make sure that you understand how the money is compounded. So this is what I need to see. I need to see oh, it's $9,000, and then it's 1 plus. I'm putting this in parentheses because in your calculator, you need to do that. If you don't put this in the calculator correctly, you're not going to get the right answer out. I tell my pre-calc kids all the time, you guys, a calculator is great, but it's only as smart as the user. And what I mean by that is if you tell the calculator, if you put in -2 squared, it'll tell you it's -4. But what is -2 squared? What's -2 times -2? +4, right? But if you put it in the calculator like this, your calculator is going to square 2 first and then multiply it by a negative. You need to tell the calculator, hey, look, I want -2 to the second power. So you have to be careful with your parentheses and stuff like that. That's where you guys are going to mess up. So it's important to have your calculator and then practice with it. So my interest rate, what's my R value? 0.0146, right? Divided by, what's my N? How are we compounding this? Quarterly, so 4. And then we're going to raise it to the what power? What are we going to raise it to? What does the formula say? 4 times 3. Now notice I did this. Let's see a different color. You see this little thing here? Most of your calculators have that. It's called a caret button. That's how you raise something to a power that's not like squared or whatever. So when you put this in your calculator, you need to follow along with me. If you don't have one, you guys need to bring one. You need to get one. But you have 9,000 parenthesis. Then hit 1 plus parenthesis. 0.0146 divided by 4. Close your parenthesis. Close your parenthesis. And then the caret button. You got to raise it to the, you can put 4 times 3, you can put 12. Did anybody do that in their calculator? And I don't care if you get it right or wrong. I just want you to practice it. Tell me what you guys got. 9,402. We're talking about money, so 21. Okay. What do you guys notice about the amount that you started off with and then what you end up with? It's pretty close, right? If you do something in your calculator, you plug it in and you get 1.3 times 10 to the E. Don't tell me, oh, my calculator's broken. You guys did something wrong. When we do this compound interest stuff, guys, when you do compound interest stuff, you're not going to get a number that is astronomically different from what you started with. It might be, thousands off, something like that, but you're not going to go from $9,000 to like $9 billion. That's just not going to happen. If you did not get that, don't freak out. You don't have to tell me right this second, but show me your calculator and we'll work through it. If you got it, great. If not, don't worry about it. We'll work through it, okay? Let's try another one. We'll come back to 7 another time. Let's go back to 8. All right, what has changed? An example 5, right? We're going to have all the same stuff. What has changed in this question? If I look at number 8. How the money is compounded, right? So your N value becomes what? 365. So we're going to do the exact same thing. We're going to start off with $9,000. Then I have 1 plus. Parenthesis, my interest rate was what? 0.0146, was it? Yeah? Guys, okay. Can't hear your head shaking. What does daily mean? 365. Okay, good. So watch, I'm going to close my blue parenthesis here, and then I'm going to raise this to the 365 times 3. So let's practice this in our calculator. I'm going to hit, do it with me, 9,000, parenthesis, 1 plus parenthesis, 0.0146 divided by 365, close your parenthesis, close it again, and then you hit that caret button. You're going to raise it. Now, some of you might have to put this in parentheses too. When in doubt, guys, put it in parentheses, but 365 times 3. That should be in your exponent. What'd you get? 9,402.95. Is that vastly different from what you got the first time? No. Some of you are like, yeah, it is. That's because you put something in wrong. And that's okay. We'll look at it. Don't freak out. We will look at it. But I want you guys to understand, when you do these interest problems, you might get one problem and you have to do it 3 different ways: daily, weekly, monthly. It should not be very different. Your answer should not be vastly different from one to the next. Like, this is real life. Like when you put stuff into an account and the interest is compounded weekly or whatever. I mean, banks aren't making a ton of money, and neither are you. So just be careful. I want to go to your homework. Can you guys pull your homework up for a minute, please? Your homework's not due till tomorrow, but I want to do a few of these with you. And then I'll talk to you, if you have individual questions about your calculator, we'll talk. If you look at, I want you guys to practice with your calculators here. If you look at number 6, what does 6 say? 6 times 2 to whatever power, right? So if we're going to evaluate using x is -2, we're going to evaluate using x is 3. We'll do it 2 ways. So I have 6 times 2 to the -2 power, and I have 6 times 2 to the 3rd power, correct? Everybody with me? Let's start on the right. What is 2 to the 3rd power? 2 times 2 times 2? 8. So 6 times 8 is 48, correct? In your calculators, guys, if you do 2 to the -3rd power, you're going to get a funny looking decimal. If I have, oh wait, was it 3rd power? Oh yeah, okay. So I have 6 here times, how would I write a negative exponent? You guys remember from a few lessons ago? How do we make a negative exponent positive? Perfect. So this would become 1 over 2 squared, right? So if you're allowed to use a calculator, decimals are fine. If you're not allowed to use a calculator, you guys need to know how to simplify this by hand. This is 6 over 1, correct? So when I multiply this, I get 6 over 2 times 2 is 4. So this becomes what? 3 over 2? You guys agree? If you did it in a calculator, you'd probably get 1.5. Some of your calculators go ahead and keep it in fractions. I'm not sure what you guys are using. But again, I'm not sure if you're allowed to use calculators or not. I got to ask Miss Carver. But you need to know how to use it if you are allowed to. I know for sure you'll be allowed to use one if there's like a calculator, non-calculator portion. You'll be able to use it for the interest problems because you have to. But if I look at something like number 7, and again, we're going to evaluate with 2 things. I'm going to evaluate, so 5 plus 3 to the -2. And then 5 plus 3, is it to the 3rd? In both cases, guys, what do you do first? Do you add the 5 and the 3? Or do you evaluate the exponent? Evaluate the exponent. So over here, we'd have 5 plus, this would become 1 over 3 squared, right? So this is 5 over 1 plus 1 over 9. If you're allowed to use your calculator, you'll get the decimal equivalent. But if we can't use a calculator, what's a common denominator between 1 and 9? What's a common denominator between 1 and 9? 9. Right? So if I multiply the bottom here by 9, then I multiply the top by what? 9, and I get 45. So then I can add across. I get 46 over 9. All right, what is that as a decimal? 46 divided by 9. 5.11111111. Something like that. All right, what do I do over here? What's 3 cubed? 27. So 5 plus 27 is 32. All right. When you evaluate, always evaluate, use PEMDAS. Parentheses and exponents are first. Everybody with? Okay? I thought you guys were going to be livelier in the afternoon. Maybe quarter four. Maybe quarter four. All right, here we go. We're going to talk about, is this a growth or a decay? Don't worry about graphing it. You don't have to do that, but we're going to identify if it's a growth or a decay. So remember, the only thing you worry about is that number that is attached to the exponent. Don't worry about anything in front or behind it. That number, I look at it, 7. Is that greater than 1 or in between 0 and 1? Greater than, so it's a growth. Perfect. So now I look here, 1/8. Bigger than 1 or in between 0 and 1? So it's a perfect. Good job. 0.75. Think money. Bigger than 1 or in between 0 and 1? So it's a. All right, you guys want about 25 of those on the test? You like those? I'm not making them, so I can't tell you. All right, just looking at this, it says to identify, is this a growth or a decay? Why? Perfect, because it's in between 0 and 1. Good. Very good, very good. It says identify the annual percent increase or decrease. So remember, if it's a growth, it's 1 plus R, right? If it's a decay, it's 1 minus. So which parenthesis am I going to set equal to 0.75? Okay. So 1 minus R equals 0.75. What do I do to both sides? Subtract 1. Think money, guys. If I have 75 cents and someone wants to take $1 from me, what am I left with? I'm left with negative 25 cents in my pocket. So R equals 0.25. Have we identified the percent? What percentage is 0.25? 25%. Good job. Good job. All right, I'm going to do the last example, and then I'm going to let you guys finish your homework. You can ask me questions about the calculator, whatever. We'll have about 20 minutes or so. We're going to do this problem 3 different ways. We have 3 accounts. Do you guys see account 1, account 2, account 3? The only thing that's going to change is what value? The compounding. What value is that in my formula? The n. Good. The n. How your money is compounded is going to change. What value do I use for quarterly? 4. What value do I use for monthly? 12. And what value do I use for daily? 365. Good. I want you guys to see how your answers will not vary a whole ton. So let's think about our formula. It is the principal times 1 plus R over n to the n times t, right? So let's do blue first. What is the initial amount that I invested? How much did I put in the account? $2,200. Okay, so $2,200. 1 plus, what is the interest rate? 3%. How do I write that as a decimal? Perfect. 0.03 divided by, in account 1, what's our n value? 4, good. And then I'm going to raise it to the n times t. Well, how many years are we talking about? 6. So we're going to raise it to the 4 times 6. So let's throw this in our calculator. 2,200, parenthesis, 1 plus, parenthesis, 0.03 divided by 4. Close that parenthesis. Close the big one. And then you're going to raise it to the 4 times 6. I'm just going to put 24. What'd y'all get? 2,632 and 11 cents. Okay. Is that a huge difference from what we started off with? No. So let's do the same thing. But now we're going to use all the same values. The only thing that's going to change is my n. So 2,200, 1 plus. Interest rate is still 0.03, but I'm changing my n value to 12, and then I raise it to the 12 times 6. So 2,200, parenthesis, 1 plus 0.03 divided by 12, close your parenthesis, and then 12 times 6. What do we get? Anybody? Anybody? All right, hold on here. 2,600, how much? And 28? 29? Okay. Again, is that very different? Very different from our original? No, but look how close it is to our two values. Over 6 years, look at the difference when you compound quarterly versus monthly. $1, right? You should not be getting crazy. Okay, so lastly, we'll look at this example, and we're going to compound daily. So our end value is going to change to 365. So we're going to start off with 2,200. Yeah. Times 1 plus, then I have parentheses. We're talking about 0.03% interest rate, and this is for 365. That's how we compounded it. And we're going to raise it to the 365 times 6. So when we do this in our calculator, 2,200, parenthesis, 1 plus, parenthesis, 0.03 divided by 365, parenthesis, close that parenthesis, and then raise it to the 365 times 6, you get $2,633.86. So if you guys notice, all three of these values are all very, very similar. So you should not get things that are crazy, crazy, crazy different.